All right. Hello, everybody. This is the Nephew SIG, whatever it is, automation package management sub-project. Thank you all for joining. All right. So like the meeting we had on Tuesday, this is very much a interactive session. Like, let's interrupt me, ask questions. We're trying to get things going. And so let's get started. All right. Let me display. All right. So I am seeing myself. All right. Okay. So looks like Sandeep, I saw you added some questions, so I can try and quickly address those. They are somewhat addressed, I think, some of them at least in the previous discussion. So yeah, it might be, well, okay. So I don't know if we want to spend too much time on it because it might be helpful for you to check out the other one, but I'll see what I can do. With respect to always creating a new draft when an upstream package version is published. Well, actually, the package variant specifies the specific upstream revision. So we won't publish a new draft until the user changes that, or some automation on top of that changes it. Right now, that's the user in R1. But in theory, right, just like you could have a controller that's looking at all your package variant sets and proposing, watching upstream repositories, seeing a new one appear, and automatically proposing that according to some policy. But by default, it does not do that. There is a discussion in the design around tracking floating tags. I don't think that's implemented, and I don't expect to implement it anytime soon, but it is a possibility to do what you're saying. It's just not something we've done yet. Does that answer your question?
Yes, it does. Thanks.
Okay. With respect to config injection, so things like, like cluster context resources. So those are sort of like, in R1, those are out-of-band provisioned resources. So just like clusters are provisioned out-of-band, it's essentially the registration record of the cluster with Nephew. So there are cases, and we'll see this as we go through the example, probably not the example we do today, but maybe an example we do another day, where you might populate those directly, alongside with the PVS. Yeah, right now they're just assumed to be there for now. Your third question. Yeah, there's a discussion. It's not just GVK, it's the GVK in name. And there's a discussion I have a comment in that link over there on the package variant, which we're going to go through a little bit, I think, today. But we can discuss it. I mean, this is not implemented yet. So we have say in how it happens. I have some ideas that I've discussed, and you'll see for myself arguing with myself over the course of a few weeks. But I think it's, in my mind, becoming clear what needs to be done. But obviously, I'm very open to input. Yes. Okay. Watching for changes. So I don't have an example in like a Nephew context, but this same functionality is very general purpose. So you could use it, for example, to provision developer namespaces in a shared cluster. And so maybe you have a developer resource and it represents all the different developers in your organization, and you want to provision development environments for them, which consists of a namespace, some resource quota, maybe some packages. And you could actually then, if a developer changes projects or needs additional resources, you can kind of, that's another example of where you might use that. I mean, there's probably 20. I don't have any offhand. The ones we have in Nefio probably aren't things that'll change often. But I think we'll learn more as we go forward.
Okay.
Yeah, your last question is a great one too. So we've been discussing this. And what is clear is that the way we did it in the workshop is kind of mixes these things in a way that is probably not good. So what this is for context for other folks, right, is in the workshop, we do injection where we copy things from the management cluster into the package. And then we also have what we called injectors, which are the things like IPAM and in R1 VLAN. And I think probably calling those injectors is a mistake. Calling that process injection is a mistake. We call because really what they're doing is specialization. We call it package specialization. And they're not really injecting things. I think we should probably retire the injector terminology and have it only refer to the process that package variant is doing. And the main point of this is that the conditions themselves, the individual condition types, probably need to be owned by a single controller. Rather than what we did in the workshop, which is when the package deployment controller failed to inject something, a different the NF injector noticed that and responded. I think that's probably the wrong approach. Because I think exactly a little bit of the issue you're calling out here, that where it gets confusing who the authority is. So does that help clarify?
Yes.
So some of it is still evolving, right? I mean, we're figuring it out. That's my current.
Especially the last one. I mean, good to know that there is going to be only one entity which is going to do the injection, and we might retire injection from the
There's
way
other
we did.
entities manage different conditions in response, right? But sort of that basic injection function during fan out is just done the once. There's still the coordinated dance. I think Wim's calling it the condition dance now. That will still happen, but we have to set up that protocol such that those conditions are managed by one entity, not multiple entities, so they don't fight over it, right? You don't want them fighting for it.
Yeah, that sounds good. Yeah. So so that will be good. Okay. Yeah. Thanks.
Okay, yeah, hopefully that's helpful. All right, so maybe to start, and like I said, yeah, Bala.
Yeah, so sorry, John. So when you say it's by one entity, could you please mention what it is? My understanding was it's a coordinated choreography. Basically, conditions could be set, and this could be satisfied by any parties, but they had to be coordinated, right? But when you said single entity, that's what I got.
I meant a single condition is managed by a single entity, a single condition type. So IPAM conditions are managed by the IPAM thing and nothing else.
Oh, got it. Okay, thanks.
Right. VLAN things are managed by the VLAN thing and nothing else. Okay. If there's an NF injection thing, or NF specializer, it's handled by the NF specializer and nobody else messes with that condition. This is the only way we can. So what we had in the workshop is when the package deployment controller couldn't find an object in the cluster to inject, we used that as a signal we use that presence of that false condition as a signal for the NF injector controller to kick in. But now we've created a relationship between those two things that's probably inappropriate. Not in the human inappropriate relationship way, but in the controller inappropriate relationship. They're sharing a condition they shouldn't.
Yeah, got it. Okay, thanks. It makes sense. Thanks.
Yeah. Okay. So what I was thinking we would talk about after addressing everybody's questions, anybody, and please, like I said, interrupt if you want. I was thinking there's two approaches we could take. One is we could just look at the package variant set design proposal and kind of go through it and see what is being proposed. The other thing we could do, and we could go through these in either order, is I have a package that starts to try and use some of these concepts. And the idea is that by defining this package and this topology and this use case, we surface the needs or the gaps in what is done today. So if you recall Tuesday, I talked a little bit, went through the current implemented behavior of the package variant and package variant set controllers. The proposal includes a bunch of additional functionality that that is not yet implemented. So I'm thinking that we might want to start with the use case to help frame and surface why those things exist in the proposal. Because part of my goal, I think our next step is to go through this process with a more sophisticated package, because I intentionally use something simple here, and make sure that the proposed functionality in the package variant in particular is sufficient to cover the needs. So what do people think about going through, what do people think? Any opinions on that? Otherwise, I'll just move forward. Okay, I'll take that as no opinions. So I will move forward with going through the use case. So I'll set up the use case, and then we'll talk about some of the problems that have to be solved in that use case. So we'll use the Jamboard again. Okay, so let's see this. All right. Okay. So like I've mentioned many times, I'm not really super intimately aware of, say, 5G core or anything, but something I know from my past is DNS. And one of the things you have with DNS is you can have pretty sophisticated architectures, but one of the things you have is a caching DNS. Caching DNS is super simple. Effectively, it's, you ask for something, it gives you the answer, and it caches it. But when you get to a large organization or a big, high performance network, you're going to need multiple tiers of caching. And so what I'm imagining is a caching DNS architecture that looks something like this. You have actually, I'll call it, you have a distribution layer. So think regional is the expectation. And at the distribution layer, theoretically, you might have multiple caches, but for now, let's assume there's like multiple instances for redundancy, but let's just for now assume it's one. You have a DNS cache. So it's just a DNS server. It's got one interface going this way and one interface going out to the internet. Or it could be like if you're using, it could be a bit of internal DNS and all this stuff, but we're not going to worry about any of that. So very simple. Maybe in a more sophisticated one, right? This DNS cache consists of many individual processes, and you have some sort of load balancer, and maybe you have some sort of L2 shared Redis cache. Like this would be a pretty sophisticated one. So this would be in the distribution layer. We would want, if I'm going to do my example, sort of really carry it out to the full extent. Eventually, I would want to do this. I would have essentially a package that represents this kind of architecture, and then I would have a separate package that represents the edge architecture, which is again just another DNS, and I'm using core DNS because I know that, and it's super simple. Another DNS server, and then you've got some, right, some endpoint edge type network here for endpoints that it's attached to. You've got a bunch of endpoints on that. And then upstream, it's talking to this load balancer. Sorry, it's not a great drawing. But, right, so it's a two-tier kind of architecture with a cache here, and then a smaller cache at the edge. The endpoints all up to the edge. So the question that we have for Nephio is like, how do we build a package or set of packages that can kind of deploy this whole architecture and can across a fleet of edge and regional distribution layer clusters. So that's the topology I'm trying to capture in my package and like sort of figure out what are the problems we need to solve? How might we structure those packages? What might they look like? Does that make sense to everybody so far? Okay, so let's look at this. For one, we need a package to represent the edge because architecturally this is quite different than the distribution, which contains these many different items. This also might have multiple references, of course. All right, so you're going to need at least two packages, one to represent the architecture of the distribution caching DNS, and one to represent the architecture of the edge caching DNS. And then what I did is I defined that in here. So the edge one, this is actually, I could run my, let me see if I can do this real quickly. That's okay. I won't. I don't want to take the time. These are based on one we have in like the Nephio packages, sort of examples thing I did from way back when. But it's very, very simple package. Basically, it's got a deployment. It's got a core file, which is the configuration file for core DNS. It's just a config map, very simple. And it's got a service for the things in the cluster, running in the cluster to access the DNS layer. The edge one, the deployment, it runs just a couple of two replicas, and they're relatively small in their memory and cache and everything. Then I have a similar one representing the distribution layer. I don't have all the fancy stuff of L2 cache and Redis and all that, but you can imagine. But what I do have is in this, because I'm in a regional cluster, or I'm in a distribution cluster, which presumably is scalable as opposed to an edge cluster, which has fixed resources, I have a horizontal pod autoscaler for my distribution one, which can allow me to have up to 40 replicas instead of the two that I fix in the edge cluster. So those represent sort of different architectural things. Otherwise, it's basically the same, except that the values in my cache sizes are much bigger, right? That's all. But so then the question becomes, okay, so now I've got those two packages. I said like I need one for each of these different architecturally different deployments of the application. Now, there's a few, the next thing I need is a way to deploy those across different clusters. Now, I could go and manually create package variant sets that refer to each of those things like an edge one here that just basically says, hey, use this package, caching DNS edge, and send it to all site type edge. And I can do similarly, create a package variant set for regional one that says use this one for regional. And then I can sort of in a sort of circular way, I can put those two together in a package. And now I can deploy them in one go, either with kept live apply to my management cluster, or if I set up a repo and config sync on my management cluster, I can deploy them using the same tools that we're using to deploy everything else, right? That UI and stuff that we have. And so that will end up, when I deploy that package variant.
So sorry to interrupt, John. I think
Please do.
you're still sharing the GitHub page.
Oh. Thank you.
Yeah, thank you.
I forgot I have to do that. Yeah. So what happens when I do that? Well, the first pack. Let's look at the. Let's imagine first. I should have said this. Let's imagine that we actually have in Nephew registered regional cluster 1 in region one. I'm going to assume for now. I'm going to assume one regional cluster per region. There could be more than one, and that would be another like case we have to deal with. But for simplicity, let's just assume we have one per we have 3 regions, and then we have R1E1, R1E2, R1E3, etc. So we have various clusters, and that means that we have registered in Nephew either a repo or a cluster resource labeled with site type regional, and edge. These are also labeled. This is labeled region R1. This is labeled region R1 as well, so that we can differentiate. We know that these edge sites go with region 1, different edge sites go with region 2, different ones go with region 3. All right, so the package variant set then is going to, so the distribution one is going to fan out the distribution package into a package variant for region 1, a package variant for region 2, and a package variant for region 3 in their different clusters. Now, there's actually no variance between these. I actually don't, at this point, have anything to introduce that's different, because all of these are talking to some upstream like 8888 or whatever, DNS server. And so I could introduce some variants if, say, there were differences between my regions, and I wanted to use different upstream DNS servers. Maybe in region 1, if I had like split DNS between an internal and an external, I might want to introduce some variants and point to a different local DNS server or something like that. But I don't have that in this case. So this is necessary really because of the assumption we make in R1 of Nephew that one repo equals one cluster. So we need separate package revisions. This results in package revisions, as we know, in their individual repos, because package variant creates revisions. That's what it does. All right, so then in the edge side, it's not going to look that different. I can draw it, but it basically looks the same. But there's one interesting thing, in that it creates instead of creating 3, it's going to create 9. Right? You're going to have Natalie's not going to draw them all, but edge 1, edge 2, down to, assuming we had, 3 edges per region, you'd get 9, or however many there are. There could be thousands. But each of those, we would want, we may need to have a difference. Here's where we start to get into some variance. Between each of the edge ones in a given region, there may be little or no difference in this particular case as well. But if you go back to our original drawing here, sorry, I have to do that separately on the computer. If you go back to our original drawing here, notice that this edge, this edge one here talks to this load balancer here. And so in each region, this is a different IP address. So the question is, okay, how do we customize the different edge instances of the package that belong to one particular region to point to a different IP address? All right, so what are our options for solving that problem? So the first problem we have, or the first problem we found so far, is regional load balancer IP is different. Okay, for different per region. Okay, so this is where we get into what are the approaches for solving this. The first approach I would think of, if this weren't DNS, is, well, we could have a DNS name that's the same. All right, that's a great solution. So now we actually don't have variance between our edge clusters. They all point upstream to the same DNS name, and then we have to figure out how to resolve that name differently. So, okay, now we have to, so what we've done is we've moved the problem. Okay, now we need different DNS per region. So that's kind of not a solution. It's a solution. It's a give the problem to somebody else in the organization to manage the DNS appropriately. So that's not really a great solution for us here. It's also not a great solution for us here because core DNS doesn't allow you to specify an upstream DNS server with a DNS name because it doesn't expect to be able to resolve DNS. So we actually need an IP address. Okay, so we can't solve it that way. That also means we can't solve it by creating a service in Kubernetes and having core DNS locally look at that service and mess with that service's definition. So we're going to have to actually figure out how to modify. So if we could do what I just said, if we could use a service, then we would be in the world of KRM, and we would say, okay, we need all of our NFIO stuff that we've been talking about would allow us to modify the upstream IP associated with that service. And so we wouldn't have to touch the core DNS configuration itself. Unfortunately, we don't have that. So we actually have to figure out two things. One is get, or let's see, what's the word? I guess inject regional IP in the package, in the edge package revision. And the other one is rewrite the non-KRM core file. I know core file means something different when your software crashes, but we call it a core file as the configuration file for core DNS. So there's actually two problems we need to solve here that we've identified by looking at this relatively simple package. This first one is what package variant and package variant set hopefully can do for us. This second one is something we'll probably need to write a custom KRM function to. The solution I would take anyway is that I would use package variant set to inject some sort of KRM resource because it understands KRM resources. And then I would use a kept function or KRM function to copy that IP address and put it into the right place in the non-KRM config map of the CorDNS instance. So now the question we have to ask is, okay, this one we can solve with if we had the IP address in the package, then we could solve this one with a KRM function. So for purposes of discovering Nefio requirements, this one's a check off, in my opinion. So then the question is, how do we inject the regional IP into the edge package revision? Okay, so let's go back. Any questions? Does this make sense? Like is it clear how I'm doing this, using this to do requirements discovery?
One question, John. I mean, how different? I mean, are you suggesting? I mean, this is like, we are going into more service level configurations, right? I mean, this is generally handled using your config map. I mean, either the problem is fundamentally you do Anycast or some kind of GOD or geo-based DNS resolutions and so on. How is? I mean. Are we trying to say how do we inject service level configurations into when you actually do a fan out? Is that the problem?
So this is a good question. So this one that I'm checking off, like this is kind of third swim lane of Nefio. So the three swim lanes being infrastructure provisioning, workload provisioning, and workload configuration. In a network function that's more sophisticated and complicated, it has netconf, it has blah, blah, blah. You may have a totally different way of doing this. You may have an operator running on the workload cluster that SSHs into some port on the function and executes some commands and reloads. We don't have to deal with that right now. And in this particular case, which is one of the reasons why choosing a simple application is helpful for discovering requirements in that second swim lane, which is really where I'm trying to play. So that's why I'm just checking this off. I can satisfy it with this simple workload with a KRM function. I don't want to get into that third part, but there are pieces of information that have to come from the provisioning process that are going to inform how that's actuated. So, in order to make, does that answer or
no? So this term, when you say terminology like KRM function, is it like kept function or?
Yeah, I'm sorry. We've been saying kept function. I'm trying to shift the terminology. It's actually called a KRM function. A KRM function, kept is like, so KRM function is actually a general thing from the Kubernetes project. So that's why and kept is a particular what they call orchestrator that runs KRM functions. So customize is another one that supports KRM functions. And then Porch is another one. And there may be others out there in the wild that I don't know about. As far as I know, customize, kept, and Porch are the ones that do it. But the point is I'm trying to get away from implying that it's a kept only technology because it's not. It's actually a general Kubernetes technology.
Got it. Yeah. Okay.
Yeah. So just to be more politically correct, I guess I'm trying to call it KRM functions. So that's just, but it's exactly the same thing. Yes, that's just a kept function, KRM function. And so that's the other way you could do this is like we could have a template for the core file and use a Helm render to do it, but like I don't want to get into that. There's many other ways you could do that. And we don't.
So I have question.
Yeah, please.
Yes, Sandeep. The first line that you did not check, it says inject regional IP in the edge package revision resource.
Yes.
Where did we get the regional IP from?
That's a good question. We actually don't have it. So let's go back to here. And let's think a minute. So how do we do that? Well, I guess you've discovered the other problem, and that's the way I'll put it. We need to, comes first, we need to figure out the regional IP. So if we go back to the this diagram, what you can see is that this whole distribution thing is actually deployed as part of deploying that package variant set. This load balancer IP, let's pretend for a moment that that's done via a load balancer service in Kubernetes, is actually allocated dynamically by the cloud provider, and we don't know what it is. So what that means is that my package here, as it's written, that includes both of these package variant sets, actually won't work. It'll only get us part of the way there. So how do what we actually need to do is we need for the edge deployment to somehow wait. I'll go back to swivel chair here. We need for it. So let's take this. Let's go to the next page. So we need for edge packages cannot be configured until distribution LB IP allocated. So this is what I call a package dependency. This is a problem we haven't solved yet.
Unless, sorry, this is Jean-Marie, unless what you put in the package is not the IP address itself, but the intent that you need an IP address.
Yes. So yes, exactly. So actually, you're right. We have solved this in the case where, and I'm going to stop right here because this could take forever. So we have solved this in the case where we're using an IPAM system that's shared between the distribution and edge clusters and can allocate that IP address for us. So that's it. That's exactly the point. So the solution we have for that, I guess maybe I can leave it on the same thing. Solution with R1 Tech. Say. The solution with R1 Tech is use IPAM. So what does that look like? That means that I have an IPAM. Here's what I'll do. I'll go to the next page again. Sorry, lots of pages. I figure it's better than. So in each package, meaning the distro and edge packages, we define an IPAM entry. What does that IPAM entry do? It has labels. The labels on that are network, I don't know what the actual names are. If Wim's still here, he could say maybe. Network instance or network is distribution.
The network instance is just the VPN is just how they get connected, but all the rest of the labels are opaque. You can use whatever you want.
Okay. Region.
Yeah.
And service. And service is we'll just say DNS. It might need to say like distribution DNS. We might need to be a little more qualified than that. So what happens is this changes per package variant, the region, whereas the others stay the same. So now when package variant fans out here, the labels set on this package revision and this package revision and this package revision, the IPAM resource, actually ends up looking like net distro region R1 and service DNS. But when we get down to this one, and it's the same for this, and it's the same for this. I'm sorry, for this one it says R2, for this one it says R3. And over here, it's all the same, except in these it's R1. And then in the ones that are below this line, it's R2. And so our package specialization IPAM allocator kicks in for each of these and looks at these labels, goes out to the IPAM, gets back an IP address, and injects it in here. These do exactly the same, but it's not allocating a new IP address. It's already been allocated. Actually, it doesn't matter who wins the race because the IPAM system is the authoritative service and gives the right IP. And it returns the same IP to all the package revisions in R1, another IP to all the ones in R2, and another to all the ones in R3. And that problem is solved using, without having to worry about package dependencies. So just like Jean-Marie said, the solution here is indirection, not through DNS. Our first, I don't know, I lost it. But one of these pages talks about how we could solve it. And we said DNS and we crossed it out. Go for that. And that's true. We don't solve it through DNS, but we do solve it through indirection, which is DNS is just a particular way to do indirection. So, so the other solution, yes, is indirection via IPAM. And now we're done. So that solves those as well. So, but the other solution, and this is kind of what I've been trying to get at, is that like we're building capabilities, and once we have a set of capabilities, there'll be multiple ways to solve the same problem with a package. So if we had a capability where we could wait for one package to be fully deployed, and then we could read a value out of that somehow and write it into another package, then that would be another way to solve this problem. It would result in a sequencing, which is probably not desirable, but would work. I actually am perfectly happy with the solution we have, which is through IPAM, except that if you're using a cloud provider, you may not have the ability to choose that load balancer IP address, in which case you can't use this solution and you need something more. So what I want to do in this next week or two, really, is I want somebody who knows more about network functions to sit down and do this exercise with a more sophisticated package. And Wim actually just put together a package for, I think a UPF, was it Wim, if you're there?
Yes, for
And-
UPF, it's just an example. I mean, it's my current view on how it could look like. But
Yeah. But that's exactly what we need, right? So this is what I think I put in the execution planning, like the first, over the next few days, I want to write up what I have so far for the package variant set proposal. Right now, it's kind of partially written up, captured in comments and other areas. And then that defines a set of capabilities. Then we have to run through an example and see how would we solve different problems that arise in configuring these packages and deploying these packages using these capabilities of package variant set. We couldn't solve it, but we could solve it by adding the Nephew capability of IP address management in this particular case. So that's what I mean by a requirements discovery process over the next couple of weeks. We're going to have to start executing on things as well, because we just don't have that much time, but we need to flush out as early as possible other problems that we haven't figured out how to solve. Yeah, Wim.
no, I was just going to say, so that's if you don't have control over the IP that gets allocated, right? Because you basically will create a service in Kubernetes and someone else will tell you the IP. It's going to, that will mean that most likely you need to have an ability to reflect the status of that CR somewhere back that you can get access to, right? That's
Yes.
that's the only, because otherwise you are not in control. So that means that you have to discover it somehow. And
Correct.
and that means that so that's, I think, how from the moment you have an ability to discover it, that's probably what needs to happen one way or another.
Yeah.
I think for now, I suspect, I'm hopeful. Let's put it this way. I'm hopeful that we can avoid having to address sophisticated package dependencies in R1 or any maybe. Yeah, Jean-Marie, it looks like yeah.
Yeah, I wanted to ask, why does it matter whether it's an IPAM or another function that gives you that IP address? Your package is a consumer of that IP address. The mechanism to get it, that shall not matter and shall not be reflected and shall not be mandating to have two different variants of your package because the underlying mechanism is different. If we are not that, we are failing at using intent.
That's a good point. So I see that as you're right, that there's from the vendor point of view, you should be able to express a need for the IP address, and then whether that gets resolved with IPAM. So maybe what that means, Jean-Marie, from an implementation, like taking that down a notch, would be that the IPAM specializer, maybe that's the word for it, in Nephew may actually want to have the ability to look up a value that a cluster load balancer has allocated. Like that would be pushing it down a level. I'm not sure. That's a great question. I don't know the answer to how we, at some point, as a vendor, you want to express, I need this IP. But then where is the line we draw for how that requirement gets fulfilled? So far, we've drawn that line. The deployer is going to have to insert some additional information to determine in their particular environment how that IP gets resolved. So I'm thinking aloud here, so interrupt me if anybody wants to. Yeah, Bala.
Yeah, it appears to me that our IPAM system needs to be configurable in the sense that it could have adapters. It has opinionated one for R1, and then it could have adapters by which it could either talk to the cluster configuration like you talked about, or some other third-party ones, or some vendor-specific one. But again, based on my understanding, John, again, I may be wrong here. I was thinking the IPAM system that we are building is the owns the responsibility of providing the IP addresses for different network functions that we are talking about. But how it obtains that IP address should be configurable through adapters. It is an open one to begin with, or it could be talking to a cloud provider through an adapter, or some other vendor-specific IPAM through adapter, or some other mechanism.
Yeah, right now it is adaptable to talk to different things, and maybe that's, I know Wim is going to hand up, but there's sort of a material, maybe not, I don't know. There may be a materially different thing around going out and allocating IPs from like a dedicated IPAM per system to going and reading an IP that was allocated as a side effect of a cluster, a workload deployed on a cluster. Maybe there's not. I don't know, but it would have to know somehow which thing to do. And I'm not sure yet that we've given it sufficient information to know that. That could be part of the function of taking the vendor package, cloning it into your organizational repository, and adding organizational level information to that package, and it being the source. So I think Wim was, Bala, if you have a response to that, otherwise Wim was next and then Jean-Marie.
Yeah, sure. Yeah, Wim, go ahead, please. Yeah.
You're on mute.
Oops, sorry. I was trying to chime in before, but yeah, so what the IPAM system doesn't do at the moment, but it has the interface to do so, is you can, if you have IPs that are somehow consumed by someone else, you can build a discovery mechanism and inject them into the IPAM. There is an interface for it. So that's one way to do it. So in other words, the IPAM discovers it, but the other one is that you have access to the API server itself directly from somewhere that basically tells you the IP that was allocated for that service. So you basically access the service object to the API system and then tell the IP. So these are the two problem options. The question is who is doing that and so on and so forth. But one is you could have a discovery mechanism to say, okay, in the IPAM we have, this is our single source where all the IP information is collected, right? So that would be a way to do it. What is missing for that is a discovery service that, but the API to inject IPs from anywhere is there. So that it's actually a CRD to do that. And then the second thing is you actually have to, access it straight to the API system. And the question is,
right. There's different ways to solve it, and we'll have to figure out. But
so I have the following question. Okay, who is responsible for deciding which mechanism is used in an environment to allocate those IP addresses?
Not the vendor.
Okay. Is it depending on function A versus function B versus function C that I'm deploying into this environment? I don't think so. So why does the variant affecting the package that I'm deploying? It should not, because we are breaking the separation of concern.
The package is expressing its needs, and then those need to get resolved by Nephi or someone.
His need is an IP address.
Right.
Whether the IP address is allocated by an IPAM, is allocated by somewhere else, or is allocated by someone who is maintaining his list of IP addresses on an Excel spreadsheet,
right?
Doesn't matter.
So from the vendor point of view, it doesn't, and it shouldn't, right? The vendor should be able to express, I need the IP address.
Even from the package that I'm deploying perspective, when I'm deploying that package, it should not matter. What the package should contain is the request for an IP address, and the mechanism to provide this IP address is depending on the environment into which it is deployed. But why, if I'm changing my mind as the SRE of that environment, and I say, oh no, I was allocating it directly, now I want to introduce an IPAM function, why should it affect the package?
Well, the package, one, you have to write the IP address into the package. Two, you have to have enough locator information to know who the authority is on that, so that whatever you're using to monitor and modify the package can connect it back to the authority. So I think I don't think it's quite as clean. I mean, I think it looks like we only have 2 minutes left. Isti has a question. I don't know, Jean-Marie, if that, it sounds like that's a longer debate we might have to have. Isti?
Just wanted to say that because we are right now talking about IP, IPAM is a natural solution in this case. But at the end of the day, if we have an injector that can read the data from any Kubernetes resource, maybe the status, maybe the spec in some cluster, that would be enough. So if we put into the package the intent, as Jean-Marie said, that I need this data, and whenever this data is available, we just need an injector, a generic enough injector that can read it even from the load balancer services status or wherever it is, and then it can inject the result back to the
right.
package.
And so I see this as a specific instance of a general class of, that's what I meant by package dependency. Other
Yes.
similar dependencies are if the package contains a CR and the CRD is not loaded in the cluster, that's another dependency. If the package has namespace resources and there's no namespace resource itself in the package, that means the namespace has to be provisioned out of band. That's another dependency. So those could be resolved in different ways. A namespace could be resolved by a human going and creating the namespace. It could be resolved by creating deploying a separate package that creates namespaces. It could be resolved by inserting a namespace resource directly in this package if you have the authority to do so. So you're right that when we get to resolving package dependencies, there may be multiple ways to resolve them, and there has to be some way of deciding which is the right way in any given case. That may be a human, it may be some sort of automation or policy, and I think those are all huge questions that we still have to answer. And so I'd love,
Yes.
there's actually an issue out there around package dependencies in the kept repo that I think I even have comments I've copied from people in this community and pasted in there in the past. So I'd love people's thoughts there, but like these are problems we have to solve either in Nefio or in the underlying platform, or maybe first in Nefio and then decide if we upstream them. I don't know, but we're out of time. I guess let's follow up on Slack, but you can see where I hope you can see where I'm going with this, that I've used a sort of simple application with a little bit more sophisticated topology of that simple application to elicit some requirements. And I hope we can do the same with a more sophisticated application. We may get different requirements out of that. So yeah, please follow up with any questions on Slack since we're out of time, but thank you all.
Thank you.
Thank
Thank you. Bye.
Yeah.
Thank you. Bye.